Welcome all to the channel Chemflix, and today we're going to discuss about the second part of organic chemistry, basics of organic chemistry, and I'm here Ravina Rafi. Okay, so once again welcome all to this channel Chemflix, and if you're new to this channel, please click on the subscribe button, and if you like this video, please click on the like button. Please don't forget about it. Okay, and also share among your friends. And today we're going to see the formation of covalent bonds, and in this part 1 we just discussed about the difference between the covalent bond and ionic bond, and also what do you mean by the covalent bond and so on. Okay, and of course you have the idea about this formation of covalent bonds. So covalent bonds are formed between the atoms, where you can see the sharing of electrons between the two atoms. For example, I'm taking hydrogen as example. You know the outermost shell contain one electron. Okay, this is the one electron of hydrogen, and one more hydrogen is there, and of course the outermost shell of this hydrogen possesses one electron. Here you can see now this both two of this electron, that means one electron from the hydrogen and one electron from the next hydrogen, it gets shared, and each of them got two electrons in its outermost shell. That is sharing of electrons. Sharing of electrons can be called as the bond formed by sharing of electrons can be called as covalent bond. Okay, so here in this session we're going to discuss about the different covalent bonds. Okay, that means covalent bonds can be formed by sharing of one pair of electrons, and such type of covalent bonds can be called a single covalent bond or single bond. And if it is formed by the sharing of two pairs of electrons, then it can be called as double covalent bond or double bond. And if it is sharing of three pairs of electrons, then it can be called as triple covalent bond or triple bond. Okay, let's see what do you mean by this single covalent bond or covalent single bond, double covalent bond or double bond, and triple covalent bond or triple bond. Okay, so this is actually covalent bond or single bond. Okay, formation of single covalent bond in hydrogen molecule. We know that in hydrogen molecule there is only a single bond between these two hydrogen atoms. Okay, so this is a single covalent bond. This is single covalent. So how this single covalent bond is formed? Okay, you know that the atomic number of hydrogen is 1. You know the atomic number of hydrogen is 1, and its electronic arrangement or the electronic configuration is, of course, it is 1. And also the valence electrons is 1. Valence electrons is 1. And one more thing, I just want to tell you that valency is the combining capacity, and if you don't know about valency, there is a video related to valency there, and I will provide you the link somewhere over here. Okay, so valency, of course the valency is also 1. Okay, and that means it needs one electron more to attain the stability. So how many electrons it needs to gain or it needs to lose for attaining the stability, that is what is called this valency or its combining capacity. And if you want to know more about valency, please go and watch the video. Okay, so two hydrogen atoms share one pair of electron. That means you know this hydrogen atom. Okay, this hydrogen atom possesses one electron in its outermost shell, and this hydrogen atom possesses one electron in its outermost shell, and these two electrons of each of this hydrogen atom got shared, and you will get one shared electron pair in here. And this formation of this bond by sharing of one electron pair can be called as single covalent bond or single bond. Okay. So two pairs of hydrogen atoms share one pair of electrons, resulting in the formation of single covalent bond in hydrogen molecule. Okay, so in the hydrogen molecule, that is H2 molecule, you know hydrogen molecule, that means H2 molecule, you can see there is only single bond. The single bond means single covalent bond. Single covalent bond is formed by the sharing of one electron pair or a sharing of a pair of electron. Sharing of a pair of electron. Okay, so this is how in hydrogen molecule you can see the nature of covalent bond. Okay, this is a single bond. Okay, you can see here this is single covalent bond. How the single covalent bond is formed by the sharing of one pair of electron. Okay, of course this P is the number of protons, and 0 this is the neutron, and 2 electron. Okay, you can see the 2 electron okay here and 2 proton here. Okay, then comes the formation of double bond. That is our second thing. Okay, covalent bond can be of three types, that is single bond, double bond, and triple bond. And now we're going to see the double bond formation. Okay, formation of double covalent bond. That is by taking the example as O2. You know O2, the atomic number of oxygen is 8, and of course the electronic configuration is 2, 6, and the valence electron is 6, and valency, that means how many electron it needs to gain. For in this case it is gaining electron, that means 2 more electron it needs to gain for attaining the stable electronic configuration, that is octet configuration. That is here 6 plus 2 is equal to 8, therefore 2 will be the valency. Okay, so it needs two electrons more to attain the stability. So it needs 2 electrons more to attain the stability. So 2 oxygen atom. Okay, 2 oxygen atoms share 2 pairs of electrons, resulting in the formation of double covalent bond in molecule. There you can see now oxygen, it is 2, 6. This is the first shell containing 2 electrons. This is the first electron and this is the second electron. So 2 electron in the first shell, and then comes 6 electron in the second shell. That is 1, 2, 3, 4, 5, 6. Okay, this is in the case of first oxygen atom. This is oxygen atom 1, and this is oxygen atom 2. Here you can see 1 electron, 2, 3, 4, 5, 6 electrons in this outermost shell, and these 2 pairs of electron it got shared. So how many of electron will get? Each of the oxygen atom will get 8 electrons each in its outermost shell. Okay, you can see here 1, 2, 3, 4, 5, 6, 7, 8 in the case of O2, oxygen number 2, and 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8 in the case of oxygen number 1. So both of this oxygen attains the stability by taking place in this type of bonding, that is double covalent bond. Okay, so 2 shared pair of electrons, you can see here 2 pair of shared electrons between these 2 oxygen atoms. It creates two bonds. Okay, that is called double covalent bond. Okay, you can see here this is a double covalent bond. This is how double covalent bond is formed. Clear? And then comes the triple covalent bond or triple bond. That is taking example as nitrogen molecule. You're taking nitrogen molecule. You can see here 3 bonds are here. That is what is called this triple bond or triple covalent bond. There you know this nitrogen, the atomic number of nitrogen is 7 and the electronic configuration is 2, 5, and the valence electron is, of course, it is 5, and the valency is the combining capacity or how many electrons it needs to gain or lose in order to attain the octet configuration. So here 3 more electrons. Okay, here you need 3 more electrons to attain the 8 electrons in its outermost shell, so the valency will be 3. Okay, so each of this nitrogen needs 3 electrons to attain the stability. That means they take part in the chemical bonding, and there you can see 2 nitrogen atoms share 3 pairs of electrons, resulting in the formation of triple covalent bond in the nitrogen molecule. You can see here this is 2 and the first shell, okay, 1, 2, and in the second shell you can see here 5 electrons, that is 1, 2, 3, 4, 5, and for this nitrogen 2, okay, that means the second nitrogen, here also 2 electrons in the first shell, and in the second shell you can see 1, 2, 3, 4, 5, and these 3 electron pairs got shared and you will get this triple covalent bond. Okay, so that is the formation of triple covalent bond in nitrogen molecule. Okay, you can see here briefly, this is the single bond. There is only 1 bond between these 2 hydrogen atoms, and here it is a double bond. You can see 2 bonds between these 2 oxygen atoms, and here it is triple bond, that is 3 bond between these 2 nitrogen atoms. Okay, that is single covalent bond in hydrogen molecule, double covalent bond in oxygen molecule. This is the electron dot representation. Please go through it. Okay, and this is triple covalent bond nitrogen. Okay, nitrogen molecule. This is the Lewis structure of covalent bond. Okay, this is the Lewis structure of covalent bond. Please note on it. Okay, then comes, this is some of the examples of covalent bonded compounds. You can see here name. This is hydrogen molecule. This is oxygen molecule. This is water molecule. This is methane. And here you can see the structural formula. Here is HHOO. O double bond O, and then O single bond H, O single bond H, and here it is C single bond H, single bond H, single bond H, single bond H. Okay, here CH4, which means here carbon, we are studying about this. Now this chapter is about carbon and its compound. Carbon, the electronic, so the atomic number of carbon is 6 and the electronic configuration is, of course, it is 2,4. That means the valence electron is 4 and also the valency is 4. And this valency is attained by sharing of electrons. So that means by covalent bond, sharing of electrons. Okay, of course. Here you can see this carbon, it got one of the electron of this carbon got shared between this hydrogen, and there you can see a bond between this carbon and hydrogen. Of course it is single bond. And here one of the electron of this carbon got shared between this hydrogen atom, and there you can see a single bond between this carbon and hydrogen, and of course these two. That means this carbon, you can see the bond between this carbon, it is, of course, it is single bond between these 4 hydrogen atom, and you will get the molecular formula as CH4 and its name is methane. Okay, and one more thing I just want to tell you that why you're dealing with organic chemistry, then spelling. Okay, spelling is important. There is an importance in spelling. For example, CH4, the name of the CH4 is methane. Okay, now only you know that it is methane. Okay, and if in the case of double bond, okay, now you're dealing with this double bonded hydrocarbon. Now you're going to study, okay, double bonded hydrocarbon. You can see that is C2H6, that is ethane. Okay, this is single bonded hydrocarbon. In the case of double bonded hydrocarbon, this ANE got substituted with ENE. And for triple bond hydrocarbons, you can see here ENE is substituted with the YNE. Okay, so this E, Y and ANE for single bond hydrocarbons. So this spelling is, you have to take utmost care while you are writing the spelling of these compounds. Okay, and of course this is ethane. You can see here 2 carbon atom. 2 carbon atom means eth. Here is only 1 carbon atom. It is meth. And there is only single bond, that is ANE. Okay, so the name is methane, and here 2 carbon atoms, that is eth, and there is only single bond. You can see here only 1 electron is, or only one pair of electrons got shared, which means ethane. Okay, this is ANE. Okay, you're going to study in details, okay, in the coming slides. Okay, then comes formation of a very large number of carbon compounds. Okay, in the first video, we just discussed about the why carbon shows a variety of or a number of carbon compounds. Why, we already asked the question, and here the answer for the question, that is carbon atoms can form bonds with other carbon atoms to form long chains, branched chains, and cluster rings. Okay, you know that long chains, for example, carbon shows this type of long chains of hydrocarbons. You can see here again this carbon attaches to another one hydrogen, and you can see here so many long chain of carbon compounds. Okay, so this long chain of carbon compounds, of course it shows branched chain carbon compounds, and of course it shows like this type of closed chain carbon compounds. You can see here this is carbon, this is carbon, this is carbon, 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 carbon. Okay, so it forms closed ring, it forms long chain, and of course it shows branched chains. Okay, you can see here it is. I will give you an example of branches. You can see here. Okay, and all the valency, the valency of carbon is 4, and you have to follow that also. Okay, so all the valencies of the carbon got satisfied in this. Okay, you can see here a branch here in this compound, and you can see here a branch, and also it is here 2 valency got satisfied. There is 2 valencies. Of course it was satisfied by the hydrogen atom. Okay, you can see here hydrogen atom. Okay, that means closed chain, it will form closed ring, and it will form it will form closed rings. Its property is called catenation. That means carbon atoms can form bonds with other carbon atoms to form long chain, branched chains, and clustering, and this property is called catenation. And the second factor is due to its tetravalent nature. You all know that carbon, the valency of carbon is 4, and due to these, since this valency of carbon is 4, it can form bond with other carbon atoms or with atoms of other elements like hydrogen, oxygen, nitrogen, halogen, etc. And this particular property is called tetravalency. And due to this catenation property and due to the tetravalency, carbon can form a wide variety of compounds, can be called as carbon compounds. And due to this tetravalency and catenation property of carbon compounds, their organic chemistry, the branch of chemistry, okay, the branch of chemistry called organic chemistry, it's originated. Okay, so that's all about today's video. Okay, hope you all like this video, and if you are like this, please click on the like button, and also please subscribe the channel if you are new to this. Okay, and thank you all. See you, bye bye in the next video. Okay.